Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 60 in physics series, where we are discussing each and every chapter topic wise, concept wise. Also we are discussing every chapter's previous year questions, and bonus for you, every Sunday we are bringing a special KPL session that is going on, KSET Premier League, where we are giving you 30 ball question paper. So 30 marks question paper, yes, and you have to answer them, and day after tomorrow will be your KCET mock test series number 6, and there will be ray optics and wave optics full chapter. So it will consist of 30 questions from ray optics and wave optics chapter, and if you have not yet studied those two chapters, you can go back to our channel, you can visit the playlist and study from that playlist. And also don't forget to join our WhatsApp group. The link is given in the description below. If you join our WhatsApp channel, you will receive the KCET question paper in our WhatsApp channel, physics, chemistry and maths. Okay, every 3 subject question paper is available in our WhatsApp channel from this Sunday. So for physics it will be match number 6, that is mock test number 6. So don't forget to like our WhatsApp channel, go there and click on the bell icon so that you get the notification as soon as we are posting an update on that channel. Now let's move on to the list of content for today's topic. Today, as you have seen, that we are going to discuss dual nature of radiation and matter. Out of that, we are going to discuss up to photoelectric experiment, and after that the wave nature, etc., the Einstein's experiment, Einstein's formula, that we are going to discuss in another part 2, that will be coming tomorrow. So before KPL to Sunday. Right, so let's start with the list of contents, what all we are going to discuss today. First of all, we are going to discuss electron emission, then we will going to discuss photoelectric effect, what is photoelectric effect, then the experimental study related to photoelectric effect. There are different types of, different person did different kind of experiments, then the observations of that experiment, implications of that experiment, and then summary. Okay, the summarize the entire experiment, so that if any concept based question comes from this part, so that you can answer those questions, right? Let us look into the electron emission first. There are 3 different types of electron emission. First is thermoionic emission. So when you heat up a metal, okay, it emits electron. So you have a metal sheet, okay, and if you heat it up, maybe physically or maybe using electrical heater, whatever method, if you heat it up, it will start emitting electron. Okay, that is called thermal electrons, okay, a thermal ion sometimes. And this is a physical process through which you are basically exciting the electron so much that it is no longer be able to stay inside the metal, but it is coming out of the metal. So this is one of the rude or crude method. Next is field emission. As the name suggests, if you apply a very high electric field, within that electric field, the electrons that is residing inside the metal, we already discussed about it, that metal has a lot of electrons free inside it, but they are not allowed to leave the metal. But if you apply a very high electric field, those electrons residing inside that metal, they will tend to move towards the negative potential, and that potential should be in the order of 10 to the power of 8 volt per meter. Okay, this is the order of the magnitude of the applied electric field. Now what is next? Next is photoelectric emission. This is the most common and widely used method. What is this? When light, yes, light that we use for our vision, so same light when suitable frequency. So frequency of the light is very important, we will see that in a while. So when light of suitable frequency illuminates a metal surface, the electrons are emitted from the metal surface. So basically what is that? If you have a metal surface, okay, the light is falling on that metal surface and it is emitting electrons. Okay, so this is one of the backbone of our modern technology, that is solar panels. Okay, they are basically based on this principle, not very easy but a complicated one, but still it is one of the very basic level principle of our solar panels, which can turn our polluted energy into greener energy, right? We know that when we burn fuels, then they produce a lot of harmful gases, but if we switch to solar solar powered devices, then basically that means we are using solar power, so no emission, no pollution, so that is a more way of getting a greener energy. So photoelectric emission is one of the starting point of this process, and here electrons are emitted when light of suitable frequency falls on a certain material, right? And these photons generated electrons are called photoelectrons. So photoelectrons means when we are basically shining light, which is basically called photon. Okay, the name of the light in Greek is photo. So from there it is came photography, photon, etc. all came from this term photo. So basically what is happening when these electrons are emitted, these electrons are called photoelectrons because they are getting emitted because of the light. Okay, now let's move on to the photoelectric effect. Okay, so basically there are few things. This process is called photoelectric emission, and based on that there are two major observations. One is Hertz observation. Hertz is the first person who did experiment using this process where he was shining light and he was observing that some charged particle is coming out of the metal. At this point of time the concept of electron was not clear. Okay, electron was not discovered till this point, so it was not clear, but he observed that ions are coming because charged particle means ions. He was not sure whether it is only one single charged particle or it was an ionic molecule, so he said it is a charged particle is coming out. But nowadays we know that that charged particle is nothing but electron, so we will refer them as electron. So when light falls on a metal surface, some electrons, so what is the asterisk is for? So asterisk is for electron was yet to be discovered. So when he observed this time electron was not yet discovered. Near the surface absorb enough energy from the incident radiation to overcome the attraction of the positive ions in the metal of the surface. After gaining sufficient energy from the incident light, the electrons escape from the surface of the metal into the surrounding space. So for example, you are being confined by your parents or by your family, so you are staying in your family home. But when you get a job, when you get enough money, you want to have your own home. Okay, you want to stay, you want to bring your parents into your home rather than staying there, right? Just an example, just consider that. So what is that? So electrons are like the kids of the metal. Okay, they do not have enough money, they are being harassed by their positive proton parents, so they are even though they are free, they are moving inside the metal, they are not allowed to move outside. But the light that is giving its energy, okay, after having enough energy, they are now self-sufficient. They are saying, no, I don't want to stay in your house, I am going out. So they are coming out of the metal. Okay, so basically the main thing that they had to do, they had to absorb sufficient amount of energy. Once that energy is sufficient, they can move out of the metal, right? So after gaining sufficient energy, it can escape the surface of the metal, it can escape the pull by the positive proton, and then it can come out of the metal. Okay, now it was found that certain metals like zinc, cadmium, magnesium, etc. responded only to ultraviolet light having short wavelength. Now this is Hallwag and Leonard's observation. Okay, Hallwag and Leonard's observation. Hallwag was one of the student of Hertz or collaborator of Hertz. Okay, so they also did some experimentation and they observed something else. It was found that the certain metals like zinc, cadmium, magnesium, etc. responded only to ultraviolet light having shorter wavelength to cause electrons emission from the surface. So basically what he observed, previously Hertz observed that if you give light, if you give enough light, electron is coming out. Okay, so energy, he spoke about energy. Here first time we are talking about type of light that was used. So he observed that they observed that metals like zinc, cadmium, etc. they require higher frequency light such as ultraviolet light. Okay, so they require higher frequency light to give electrons. Okay, they can only absorb higher frequency lights as but they do not emit any electrons if you are giving higher wavelength of light. For example, they will not emit electrons if you are giving red light, which is lower in frequency but higher in wavelength, it will not work. We will see all the things will be coming together at the end of the chapter. When we conclude this chapter, all these questions, why it is so, why only higher wavelength is not working but higher frequency is working, everything we will discuss at the end of the chapter, that is in our next part. But for now you should remember that it is dependent on the short wavelength. Okay, shorter the wavelength, better chance is to get the photo emission. Now however, some alkali metals such as lithium, sodium, potassium, cesium and rubidium were sensitive even to visible light. So visible light has higher wavelength light. As I said, ultraviolet is above violet, so that means it has higher frequency but lower wavelength. But visible light has higher wavelength but less frequency. Out of that, violet has the smallest wavelength, red has highest wavelength, right? Everything we discussed. All these photosensitive substances emit electrons when they are illuminated by light. Okay, they all illuminate electrons, they all emit electrons when they are illuminated by light. After the discovery of electrons, these electrons were termed as photoelectrons. We have already mentioned that in the beginning of our lecture, that these electrons are called photoelectrons. At that point of time when they were doing the experiment, even during Hallwag and Lennard's experiment, electrons was not discovered. Okay, as we know, J.J. Thomson discovered electron much later time. Okay, and after they are discovered, they realized, okay, whatever is coming out of the metal surface, that is nothing but electrons, and let us call it photoelectrons. Okay, the phenomenon is called photoelectric effect. So this process of emitting electron when light is being falling on certain material is called photoelectric effect. Okay, now let us discuss about experimental study. So how they have observed different things when they have started doing the experimentation. Okay, first of all, let us discuss the apparatus. So we have a glass tube. Okay, glass tube, specially designed glass tube, and in this glass tube, if you see, you can throw light from this opening. Okay, so this is a window through which light can fall, and here we have a special photosensitive material, okay, on which when light is falling, it can emit electron. Now it is imperative that it need not to be necessarily the sensitive material that we are experimenting with. You can take a very small amount of metal and you can coat it with that any other material, then you still get the photoelectric effect. Okay, so suppose I want to produce photoelectric effect using zinc. I don't need a full zinc plate. I take a very thin layer of zinc on top of, say, some other material, say iron, then also it will work. Okay, whatever surface is outside, that is the main thing that is emitting photoelectrons. Okay, now so light is falling through this window on the surface, and after that the electrons are getting emitted. Okay, and electrons are getting emitted from this side to this side. Okay, now here we have created an external power supply. We have attached an external power supply, and what we are trying to do, we are applying potential such that these electrons sometimes don't get accelerated. Okay, the electrons are we are trying to stop that electron by applying negative potential to this and positive potential to this. Sorry, we are applying negative potential to this so that it gets repelled from this side, and positive potential to this so that they are getting attracted. So they are getting produced by the metal, but we kept the metal as in positive potential, so that what is happening, the electrons which are getting out, they are again getting attracted back towards the metal. So basically what is happening, you are getting energy, you are thinking, oh, I will go out, but again after you losing the energy, that is you lose the money, then you are going back, oh, I have to go back to home. Okay, so this is the case. So the setup is like that. So electrons which are going out of the metal, they are being forced to go back, and based on that there are certain observations, certain things that we are going to discuss. First of all, let us discuss the number of photoelectrons emitted per second is directly proportional to the intensity of the incident radiation. So if nothing is there, okay, So if there are no other arrangement is there, the circuit is in off position, okay, you are switching on the light is falling on this metal and it is emitting electrons. How many electrons will be emitted? So 1, 2, 3, 4, 5, 6, 10, 20. How many electrons will be emitted? That is directly proportional to the intensity of the light. Intensity of the light means, suppose you have a 6-watt torch. Okay, now you are we have switched it on and you are seeing, okay, 10 electrons are emitted. Now if instead of 6 watt, if you switch it on at another 6-watt torch, okay, the intensity is doubled. So intensity is doubled means now the light which is the electrons which is being emitted will be also doubled, so it will become 20. Remember that the number of electrons or photocurrent, we will term it as photocurrent later on, this is independent of anything else. Okay, it is independent of frequency, it is independent of wavelength, it is independent of speed of light, it is only dependent on the intensity of the incoming radiation. Okay, if the light is intense, that is very bright, then you will get more number of electrons. Okay, and if the light is not bright, you will get less bright of electron. Now if you plot photoelectric current, that is number of photoelectrons emitted per second. Okay, so photocurrent is nothing but number of electrons emitted per second. So number of electrons emitted per second. Now number of electrons is directly related to intensity. So photocurrent is also directly proportional to the intensity of the incident light. Now remember that photocurrent, even though it is photocurrent, we say IP. Intensity is also represented by the symbol I. Photocurrent is also represented by symbol I. So if you get confused, don't worry. In photoelectric effect, we never mention photocurrent as current I. We will only mention intensity as I. Photocurrent is just a starter. You can say this is just a starter. Most cases frequency is more important, intensity is more important. They plays more major roles. Okay, energy plays major role, but photocurrent is the starting point because the number of electrons coming out per second is kind of current, so that we are calling it as photocurrent, right? So intensity of the light, if you increase the intensity of the light, photocurrent will increase. Okay, there are certain restrictions, obviously we will discuss about that in a while, but if you increase the intensity, photocurrent, they are linearly dependent. That is very, very important. Okay, so it is linearly dependent. How can I say this is linearly dependent on intensity? If you see the curve is a straight line. Okay, so more intense the light, more number of photoelectrons is coming. Also, it is directly proportional because this line is straight. So straight line graph means it is directly proportional. If it is a square proportional, then we know that it will be a curved line, right, going slowly upwards. Now let's move on to the second part, effect of potential on photoelectric current. The maximum value of photoelectric current is called saturation current. So maximum value of the photoelectric current is called saturation current. So if you are not doing anything, you just simply completed the circuit. If you just simply complete the circuit, there are situations that you can simply complete the circuit without involving the battery, then there will be a current flowing in this direction, as we know. So electrons are moving in this direction, so current will be flowing on the opposite direction, right? So the photocurrent will be flowing in this direction, photocurrent will be flowing in this direction. Okay, so if you just simply remove the battery or disconnect the battery for a while, then you will observe the photocurrent which is coming out of the battery is has a saturation point. Okay, so after some time the maximum number of electron that is coming out of the metal is a constant. Okay, so saturation current corresponds to the case when all the photoelectrons emitted by the emitter plate C reaches the collector plate A. So all the electrons which is being emitted by the emitter, they are all being reached to the collector. So emitter is the left hand side from where the electrons are getting emitted, and collector is where electrons are getting collected. Okay, now if you plot the graph, okay, so basically what is that, if there is nothing is there, no external potential is applied, then you will get the graph like this. Okay, you will get the graph like this. So this is a saturation point. Saturation point means no matter how you increase the potential, the current will not change. Okay, so current will not change, current will remain constant. Okay, current remaining constant means potential, even if you have applied positive potential. Okay, so positive potential means you are trying to get all the electrons out of the metal, still after some time you cannot increase the current. You remember that in Ohm's law current was proportional to the voltage, so it was a straight line graph. But in case of photoelectrons, it is not a straight line graph passing from the origin. It is after some time it is getting flat with y-axis, sorry, flat with x-axis. Flat with x-axis means it is becoming a constant. Okay, flat with x-axis means it is becoming a constant. But if you apply a negative potential, okay, so after you apply a negative potential, after some time, okay, all the electrons are going back home, so you are not getting any photocurrent. So here the photocurrent journey of the photocurrent ends. Okay, this is called stopping potential. So at this potential, or if you apply more negative potential, this is the minimum value where all the electrons which was coming out of the metal will stop. Okay, they will remain at home. So this is the minimum value, and this is called stopping potential. If the potential you apply, even if it is negative, if it is more than this stopping potential, electrons will immediately come out of the metal. Okay, the minimum negative potential V0 given to the plate A, for which the photocurrent stops or becomes zero, is called the cutoff or stopping potential. Cutoff potential or stopping potential, both are same. But here what is happening, when you apply the potential in the negative side, then the electrons will not come out of the metal. They will all stop, obviously, because you have applied positive to the emitter. So electrons which are going to come out, they are already home. Okay, so they will not come out. So this is the stopping potential. If you apply positive potential, you are expecting, okay, the electrons are coming out. Now I have applied positive potential, so the current should increase exponentially. I should get a very high amount of current. No, that is also not going to happen. After some time, the current will also stop, and they will also reach a saturation point, and current will also become constant. That means all the electrons coming out of the proton, they are emitter plate, they are all reaching the collector plate simultaneously, and you are getting a constant current. Okay, now effect of frequency on the incident radiation from stopping potential. Now let us discuss about the effect of frequency. So far we have assumed that when light is falling on the emitter plate, it is emitting electron, and those electrons are getting absorbed by the collector. That was our initial assumption, and also we have fixed the frequency for all the tests that we have done so far. Now we are trying to change the frequency, and we will observe what all will happen. First of all, the minimum negative potential V0 given to the plate A, for which the photocurrent stops or becomes zero, is called the cutoff or stopping potential, and it is different from different frequency. So for example, if we apply three frequencies, nu0, nu3, nu2, nu1, okay, and as you can see that nu3 is maximum, nu2 is in between, and nu1 is minimum frequency. Now for the maximum stopping potential is for when you have applied the highest frequency. So stopping potential increases with frequency. Stopping potential increases with frequency. Right, stopping potential increases with frequency. Okay, if frequency is constant, stopping potential will remain constant. Okay, so saturation current depends on the intensity, stopping potential depends on frequency. Okay, so more intense the light, more is the saturation current. Highest amount of current that you can get is dependent on the intensity of the light. So that's why when you are installing say solar panel, you are getting maximum amount of current at 12 o'clock. Okay, and you are getting minimum current during early sunrise and sunset. So sunset and sunrise you are getting least amount of current, because it is dependent on the intensity of the sunlight, and it is maximum at midday, at noon, where you are getting maximum sun. Right, now let's move on. let's solve one numerical question, very simple, not numerical, it's a conceptual question from your previous year question paper. The following graph represents the variation of photocurrent with anode potential for a metal surface. Here I1, I2 and I3, not cubes, okay? I1, I2 and I3 are names. Represents intensities, and gamma 1, gamma 2 and gamma 3 represent frequency of the curves 1, 2 and 3 respectively. Okay, so what they have said, so gamma 1, gamma 2, gamma 3 are the frequencies. So gamma 1, gamma 2, gamma 3, these are the frequencies, okay, and I1, I2 and I3 are the intensities. Okay, now they have asked you which of them are true. So first of all, let us understand. So these two lights 1 and 2, they have the same stopping potential. If they have the same stopping potential, as I said, stopping potential dependent only on frequency. So stopping potential dependent on frequency means from this graph we can say that I1 1 and 2 should have the same frequency. So gamma 1 should be equals to gamma 2. Clear? This much is clear. Now if you see I2 and I3, they have the same photocurrent, the same saturation photocurrent, right? So 2 and 3, they have the same saturation photocurrent. Saturation photocurrent depends on intensity, so we can say that intensity of 2 is equal to intensity of 3. So from this we can say that gamma 1 equals to gamma 2 and I2 equals to I3. So from the given option you can see that I2 equals to I3 is not given anywhere, but it is given that gamma 1 equals to gamma 2 and I1 not equal to I2. Obviously I1 is not equal to I2. They are different because they have a different saturation current. So be careful when you are answering this question. I1 is not equal to I2 is an option, so you have to choose the correct option, and gamma 1 is equal to gamma 2. Obviously it is correct because they both have the same stopping potential. Now let's move on to the next part. Now let us look into some observations. What are the observations? First of all, the stopping potential V0 varies linearly with the frequency of the incident radiation. Now we are talking about the relationship between stopping potential and frequency. So previously we are there with the photocurrent graph. Now photocurrent graph is done. Now we are discussing about stopping potential and frequency directly. So we are changing the frequencies, different lights we are using, and we are observing how the stopping potential is changing. Okay, so that's how they have measured it, and they have measured it for two metals, metal A and metal B. And what they have observed, that it is varies linearly, not exponentially, not any square, not with square, not with 1 by square, not inverse or anything else. They are dependent directly, and it is a linear relationship, right? So stopping potential V0 and frequency of incident, they are linearly dependent. Okay, there exists a certain minimum cutoff frequency gamma naught for which the stopping potential is 0. So there is a certain minimum value of stopping potential, okay, that is called nu naught. Below that there is no potential, right? So if you go below nu naught, then you will not get any current at all. If you go below nu naught, you will not get any current at all from the photosensitive circuit. Okay, this is the minimum value for which the stopping potential is 0. That means the electrons are just started to come out. Okay, this is the minimum frequency. If you go below that frequency, you will not get any photo emission. Okay, so this is called threshold frequency. The maximum kinetic energy of the photoelectrons varies linearly with the frequency of incidence of radiation, but is independent of its intensity. So this is the implication, as I said. So stopping potential is dependent on frequency but independent of intensity. Okay, so stopping potential does not depend on intensity, does not matter how much intensity light you make it, but if the stopping potential is something that will remain constant, right? One more thing, if suppose I have a surface, okay, metal surface, its minimum frequency is say 5 Hz, This is the threshold frequency. The minimum frequency that is required for light to emit is called threshold frequency. If the threshold frequency is suppose 5 Hz and you have two lights, okay, one is 5 Hz and say intensity 1 watt per meter square, okay, and a second light say 3 Hz but intensity 300 watt per meter square. Now which one do you think will emit more number of electrons? Which one will have highest amount of photocurrent or saturation photocurrent? Okay, so this is the threshold frequency. So any light of 5 Hz will still emit some electrons, but this is below photocurrent, so it will not emit any electron. Okay, it will not emit any electron because its frequency is less than that of the threshold frequency. Even if it has a 300 watt per meter square, there is very high intensity of light, but if its frequency is less than that of the required, it will not emit any photocurrent. Okay, so for a frequency of incident radiation lower than the cutoff frequency, no photoelectron emission is possible. This is actually nu naught. Okay, no photoelectron emission is possible even if their intensity is large. This minimum cutoff frequency is called the threshold frequency. It is different for different metals. Now threshold frequency varies from metal to metal. We have seen the previous diagram, metal A, metal B, one of the metal has a lower threshold frequency, another one has higher threshold frequency. So threshold frequency dependent on the material. Now let's look into one more problem. Light of certain frequency and intensity incident on a photosensitive material causes the photoelectric effect. If both the frequency and the intensity are doubled, the photoelectric saturation current becomes halved, unchanged, quadrupled, doubled. Now we know that photocurrent depends on intensity, it does not depend on the frequency. As long as the frequency is higher than the threshold frequency, it will start emitting light. Okay, only thing frequency determines whether it will emit light or not. Simple as that. Okay, so if the frequency is more than that threshold frequency, it does not matter. As long as intensity is same, the photocurrent emitted by the light will be same, and if you increase the intensity, then photocurrent will be doubled. Okay, here you have doubled the intensity, so photocurrent will be doubled, not quadrupled, because it is independent of the frequency. Remember this point. This is very common trap coming in KCET exam. Now let us look into the summary of all the things that we have done today. For a given photosensitive material and frequency of incident radiation above the threshold frequency, the photoelectric current is directly proportional to the intensity of the light, okay, of the incident light. For a given photosensitive material and frequency of incident radiation, saturation current is found to be proportional to the intensity of the incident radiation, whereas the stopping potential is independent of its intensity. Stopping potential depends only on frequency, okay, and current depends only on intensity. So they are individual, okay. Now for a given photosensitive material, there exists a certain minimum cutoff frequency of the incident radiation called threshold frequency. Now we all know all the names, so from now on we will use these terms very frequently, below which no emission of photoelectrons takes place, no matter how intense the intensity of the light is. Okay, above the threshold frequency, the stopping potential, or equivalently the maximum kinetic energy of the emitted photoelectrons, increases linearly. So what they have now joined is the stopping potential, okay, the stopping potential, or equivalently the maximum kinetic energy. So now we are slowly mixing potential with kinetic energy, right? So we have started mixing potential with kinetic energy, and in our next lecture tomorrow we will see how they are related also. Okay, emitted photoelectrons increases linearly with the frequency of the incident radiation, but it is independent of its intensity. Very important. Okay, threshold frequency is independent of the intensity, but it is dependent on the frequency of the light. Now, photoelectric emission is an instantaneous process. So instantaneous process means what? As soon as you show the light, electrons will start come out. Okay, they will not wait. Okay, they will not say, okay, I am receiving less amount of heat, so I will emit slowly. As long as the frequency of the light is more than that of the threshold frequency, even if you switch on a very dim light, okay, it will start emitting the light. So they have said that the gap is 10 to the power of minus 9 seconds, very, very small. Even when the incident radiation is made exceedingly dim, means very, very dim. Okay, so even sun is about to go down, okay, during sunset, still there will be some production of photocurrent. Even though there is small, there will be a very small amount of photocurrent still at the end. Okay, so even during the early morning when the sun is about to come out, at that point of the glow is there, so the photoelectric effect will start happening. Okay, it does not matter, as long as there is a very dim light of appropriate frequency, the photoelectric effect will continue. Okay, now this is the homework. Solve this homework, pause the video, read the question. Very simple homework for today. Okay, solve the homework, mention the answer in the comment below. I will discuss these two homework questions in tomorrow's lecture. Okay, and tomorrow we are going to discuss about Einstein's equation, obviously de Broglie wavelength, etc. More complex topics. So don't miss tomorrow's class. Okay, I'll be back with a complete new lecture of this chapter. Okay, this is also homework number 2. I am going to be discussing this as well. Pause the video, answer the question and mention the answer in the comment below. Now, if you want all the videos available at one place, the only thing that you have to do, you have to bookmark this playlist. Okay, all the latest videos are available in this part. Okay, you have to bookmark the playlist and you have to download. You can download, you can watch at any time at your own pace. Okay, only thing you have to bookmark this place, and to participate day after tomorrow's KPL, you have to download WhatsApp and follow our channel. The link is given in the description. If you follow WhatsApp channel, and don't forget to click on the notification icon so that you get all the notification as soon as we are posting the question, as soon as we are uploading a video, you should get the notification. So and if you think this is helping you, don't forget to subscribe to our channel. I'll be back with part 2 of photoelectric effect tomorrow. Till then, tata, bye bye.